This video is explaining more about solving using the quadratic formula. So these problems, we have 4 examples on here. We're going to solve the following using the quadratic formula. We're going to write our decimals as decimal approximations to the nearest hundredth when possible. If we have real rational solutions, we will answer them as real rational solutions. Otherwise, we'll have them to the nearest hundredth. So as before in a previous video, I explained that you need to have your quadratic into standard form. So I have it equal to 0, and then we'll use the quadratic formula. So the first step is to get this first problem into standard form. The 4x is on the wrong side. We do have a positive x squared, and you always want to have a positive x squared. It makes things much easier. So what we want to do is subtract the 4x to the other side. So we'll end up having x squared, positive x squared. We're going to subtract the 4x, but then we'll keep our positive 6 equal to 0. We need to find our a, b, and c, so we can use our quadratic formula. So a is equal to a positive 1, b is equal to a negative 4, and c is equal to a positive 6. So using the quadratic formula, I'm going to rewrite the quadratic formula up here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now notice that I extended my all over from the negative b all the way to the end of the c. My x is completely alone because we're solving for x. Now again, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So everywhere I see a letter in my quadratic formula, I'm going to put parentheses, except for the x. So we have x equals negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses all over 2 parentheses. Now I'm going to plug in my letters for that. For the b, negative b, I put the negative 4 because that is my b value. Then I have b squared, so I have that negative 4 minus 4a, so I put in the 1. C, I put in the 6. All over 2a, I put in the 1. So I do as much of this without the calculator, so the outsides I do without the calculator. So I end up having x equals, I'm going to have a negative times negative 4 is a positive 4, plus or minus, I'm going to have the square root of something. I will figure that out in just a moment. All over 2 times 1 is 2. Now I'm going to go figure out what's inside the parentheses using my calculator. This again is called the discriminant. It's called the discriminant. It tells you how many and what types of solutions we're going to have. So I'm not going to use the square root symbol. I'm just using parentheses. Negative 4 parentheses squared minus 4 parentheses 1 close parentheses 6 close parentheses. I press enter. I get a negative 8. So inside the radical I put a negative 8. Now what that tells me, that is our discriminant. So discriminant equals negative 8. If you go back to the notes on the discriminant, if the discriminant is a negative, it is less than 0. If the discriminant is negative, that tells us that we are going to have 2 imaginary solutions. That means I cannot put this into my calculator. That means that our solution will actually be almost similar. It will be very close to looking like this. The difference being is that I'm not going to put any of this into my calculator. The imaginary part comes from that negative on that 8. So what we do, instead of keeping the negative on the 8, we bring out an imaginary number, which is I. That negative part is what gives us the imaginary. So what we do is we have x equals, everything else will stay the same. So we have that 4 plus or minus. But because we have the square root of a negative, that's where we come the I. We're going to put the I, this little fancy I, outside of the radical, directly outside of the radical. It doesn't go anywhere else. It has to go directly outside the radical. It cannot go before the plus or minus, so you have to make sure you have that plus or minus, then the I. Now the reason that I came out is because we actually took out the negative from the radical and it made it the I. So now the only thing left inside the radical is that 8. And we'll keep it all over 2. And this, because it's imaginary, we're actually just going to keep our answer just like this. We don't have to do anything else with it. Now we look back, we have 2 solutions. The reason we have 2 solutions is because it's 4 plus the rest of it, and then we'd have 4 minus the rest of it. So there are 2 solutions because of that plus or minus. We have imaginary because of that I. As soon as you see that I, that means that you have imaginary solutions. That means that our discriminant, since it was negative 8 to imaginary, we were correct in our solution. So if we look at number 2, we're going to do this one using quadratic formula. We need to get it in standard form. It is equal to 0, but the problem is that our x squared, our quadratic, is a negative, and you never want that. You always want this to become a positive. So what we're going to do is actually move all of these to the other side by adding the 3x squared, adding the 8x, and then subtracting the 16. So we'll end up with a positive 3x squared, a positive 8x, and then a negative 16 equal to 0. Now yes, I could have had the equal to 0 on the left-hand side, but it would be the same thing as having it on the right. Now that it's in standard form, we can find our a, b, and c. A equals 3, b equals 8, c equals negative 16. We're going to use the quadratic formula, so everywhere I see a b, or c up here, I'm going to put parentheses. So I have x equals negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses all over 2 parentheses. Everywhere I put parentheses, I'm going to put the letter that's associated with it. So b comes first. So I'm going to put the b, the 8, inside the first parentheses. Then we have b squared, so I'm going to put the 8 in there. Minus 4a, 3. c is negative 16. All over 2a is 3. So I'm going to do the outsides without a calculator. So we'll have x equals negative 8 plus or minus the square root of, I'll figure that out in just a second, that's our discriminant, all over 2 times 3 is 6. So I'm going to go figure out the discriminant by plugging in the inside of the radical. So that is parentheses 8 parentheses squared minus 4 parentheses 3 close parentheses negative 16 close parentheses equals. That's 256. So I can put 256 inside of here. So that's our discriminant. D equals 256. Now, since it is positive, we know that, and it's not 0, we know we will have 2 real solutions. Now, the question is it going to be rational or irrational? So really, is 256 a perfect square or not? So by checking that, to check that, we take the square root of 256. We get 16. So since it gave us a nice clean number, that means that it is a perfect square. So that means we're going to have 2 real rational. That means our answers will either be nice clean fractions or nice clean whole numbers, but our solutions will be nice and easy to write. We're not going to have any decimals. So our first one that we're going to do, we're going to separate them into our 2 solutions by using the plus or minus. So we're going to have x equals negative 8 plus the square root of 256 all over 6. And then we're going to have x equals negative 8 minus the square root of 256 all over 6. So we're going to use our calculator to plug these in. So I'm going to do the top part at the beginning. So we're going to have negative 8 plus the square root of 256, and I'll press enter. And then divide by 6, press enter. Now again, we didn't want any decimals because they're supposed to be rational. So I should turn this into a fraction. I turn this into a fraction by pressing math, enter, enter. And it turns into 4/3. That lets me know that it was rational. So x is equal to a positive 4/3. Now the second one, I can do the same thing by doing negative 8 minus the square root of 256, press enter, divide by 6, press enter, and I have x equals negative 4. So x equals negative 4. So going back to my discriminant, I have two solutions. That's true. They are real because they don't have any I with them, and they are rational. I can write them both as fractions, so we're good. Just because our answer has a negative does not mean that they're imaginary. Imaginary comes from the negative inside of the square root. So that means that we're good. If this value had been negative, then we would have imaginary. So our discriminant told us what we would have, and we have them. So that's good. Moving on to this third one. We again want to put this into standard form. Our x squared is already positive, so we're going to subtract the 4x and then add the 1. So we have x squared minus 4x plus 1 equals 0. So using the quadratic formula, we have a equals 1, b equals negative 4, and c equals 1. So I'm going to take the quadratic formula, and everywhere I see an a, b, or c, I'm just going to put the parentheses. So x equals negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses all over 2 parentheses. I'm going to put the value for the letter that it's associated with. So it's negative b, so I'm going to put negative 4 inside the parentheses, plus or minus square root of b, so I'm going to put the negative 4, squared minus 4a, so I'm going to put the 1, c, I'm going to put the 1, all over 2a, I'm going to put the 1. So the outsides again I'm going to do by hand. So I'm going to have x equals negative times negative 4 is a positive 4, plus or minus the square root of something, I'll figure that out in just a second, all over 2 times 1 is 2. Now, to figure out the inside using our calculator, again, this is called the discriminant. I'm going to put in there whatever I have up here, so parentheses, negative 4 parentheses squared, minus 4 parentheses, 1 parentheses, 1, close parentheses, enter. I get 12. So I'm going to put 12 inside of the radical. And again, that represents our discriminant. So discriminant is equal to 12. Now, since it's positive, we will have 2 real. But 12, is that a perfect square? So I take the square root of 12. And it does not give me a nice clean number, so that means that it will be irrational. So 2 real irrational solutions. That means our final answers will be decimals. So we're going to separate them. X equals 4 plus the square root of 12 all over 2, and x equals 4 minus the square root of 12 all over 2. So I'm going to show again on the newer calculators. I've already shown how to do these up here by doing the top, enter, then divide by the bottom. And on the newer calculators, I'm going to show you how to put them in as an entire fraction. So I'm going to go to alpha, y equals. I'm going to get that first one because it's a fraction, numerator over denominator. I'm going to put 4 plus the square root of 12 over 2. Enter. And I get 3 and 73 hundredths. And because they're supposed to be irrational, it means that this should not go back to a fraction. So if I press math, enter, enter, it does not go to a fraction, so that's supposed to happen. So x is approximately, it was 3 and, so this 2 right here will keep the 3 as a 3. So 3 and 73 hundredths. And the second one, now with the newer calculators, you can press up until you get to that equation that I had earlier. That I'm going to press enter. But instead of saying plus, I'm going to go over here, over to the right, or sorry, to the left until I get to that plus. I'm going to change it to a minus. I'll just press enter, and now I get 20, that 7 will make that 6 go up to a 7, so it should be 27 hundredths. So x is approximately 0 and 27 hundredths. Now I could just go back and do 4, so alpha y equals, first one, for minus the square root of 12, go down, put 2 on the bottom, I get the same answer. So again, you can always press up until you get back up to that expression that you put in there. And then you can just replace the sign with the other sign that you needed. Now going back to our discriminant, it says we should have 2 real, so there are no imaginaries in here, so that's good. Irrational means that we should have had really weird numbers, so our decimals. These are rounded to the nearest hundredth. We cannot write them as a fraction, so that means that our discriminant was correct. On this last problem, there's a bit more that you have to do in order to put it into standard form. We have 2x squareds on here, so we have a -6 and a -9. Now we have to move one of them. Now if we move the -6, we'd add it to the -9, but that would leave us with a -3. But if we add the 9 to the other side, that'd be 9 minus 6, which would give us a +3. So what that tells us is that we want to move the 9, therefore we want to move this -3 as well. So we're going to move this, the right-hand side of the equation, over to the left. So we're going to add the 9x squared to the other side. So 9x squared and a -6x squared gives us a 3x squared. We're not moving any x's, regular x's, so we're going to have to keep a +9x. But we are adding a 3 to the other side, so a -18 plus 3 is a -15, is equal to 0. Using the quadratic formula, a is equal to 3, b is equal to 9, c is equal to -15. So again, using the quadratic formula, x equals negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses all over 2 parentheses. Now inside the parentheses, I'm going to put in the numbers that relate to them. Negative b, so I'm going to put that 9 inside that parentheses, plus minus square root of b, so put the 9, squared minus 4a, put the 3, c, I'm going to put the -15, all over 2a, I'm going to put the 3. I'm just putting the numbers in where they go. And now we're going to do as much as we can by hand. X equals, negative times 9 is just a -9, plus or minus the square root of, I'm going to figure that out in just a second using the calculator, all over 2 times 3 is 6. So calculator, we're going to put the stuff inside the radical. That's also called the radicand, which again, at the quadratic formula, is called the discriminant. So I'm going to put that parentheses, 9 parentheses squared, minus 4 parentheses, 3 close, open parentheses, -15 close. Enter. I get 261. So I'm going to put that inside the radical. And again, that tells us our discriminant. Our discriminant, d equals 261. Now it is positive, so that tells us that we will have 2 real, but will they be rational or irrational? So I take the square root of 261. Gives us not a clean number, so that means that these is not a perfect square. That means that we'll have irrational. Irrational. So our answers will end up being decimals. So separating them, we have x equals -9 plus the square root of 261 all over 6. And x equals -9 minus the square root of 261 all over 6. So again, using your calculator, we're just going to get to the nearest hundredth. So I'm going to do them separate. So -9 plus the square root of 261, enter. Then divide by 6, enter. You have to remember to divide. This is a decimal, and if I press math, enter, enter, it does not give me a fraction, so this is irrational, which is what it should be. So we want 2 decimals. That 2, we look at the 2, does not make the 9 go up, so it's going to be 1 and 19 hundredths. X is approximately 1 and 19 hundredths. We're going to do the same for the second one. You can put it, if you have the newer calculator, you can press alpha y equals the first one. So we have negative 9 minus the square root of 261, and then press down, and then put 6 on the bottom, enter. This time we get, again, a decimal. We look at the third number, which is a 2. I don't care about any of the other ones. We look at the 2. The 2 does not make the 9 go up, so it stays as a 9. So this is negative 4 and 19 hundredths. X is approximately negative 4 and 19 hundredths. Negative 4 and 19 hundredths. These are two solutions. So again, go back to the discriminant. It says we should have 2. We do. Real, there's no I because we have no negative for the discriminant. And they should be irrational. Irrational means that they're going to be in the nearest hundredth. So we were correct in our discriminant. Told us what we should have, and we do. We have those solutions. So this is how you use the quadratic formula. And we always use the discriminant to make sure that we are on the right track and that our answers do line up to what they should be. So again, you're just using the A, B, and C to plug into the quadratic formula. The quadratic formula again was x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.